In this tutorial we're going to be having a look at summing arithmetic series, but in particular summing series where the lower limit isn't the number 1. So let's have a look at this question here. It says a sequence has terms u1, u2, u3 defined by 3n plus 2 for n greater than or equal to 1. Write down the values of u1, u2 and u3. Okay, so let's have a look at this. So u1, also denoted a, is, well, it happens when n equals 1. So it's 3 lots of 1 plus 2, which is 5. u2, 3 lots of 2 plus 2, which is 8. And u3, 3 lots of 3 plus 2, which is 11. Part 2, state what type of sequence S is. Well, given that this tutorial is on arithmetic sequences, pretty obvious that the answer is arithmetic. What makes it an arithmetic sequence is the common difference, so the terms go up by 3 each time. Now for the harder part, find the sum of all the terms from the 101st term to the 200th term. Well, actually, now's when we consult our formula book, and we'll see that the formulae for sum of series are a half n 2a plus n minus 1 d, or half n a plus l. Now both of these formulae are applicable in this case. I will go through both formulae and how to use them now. So, first of all, if we're using this first formula here, this one here, we want to find the sum of the first 200 terms. However, this is the sum of all the terms from 1 to 200. We only want to start at 101. So actually, the first 100 terms we don't want. So we're going to take out the first 100 terms, leaving us with the sum of all the terms from 101 to 200. Okay, so S200 equals half 200, 2 lots of the first term, which we can see there is 5, plus n minus 1, 200 minus 1 is 199, times the common difference, which we saw was 3. Okay, putting that in the calculator. So 1/2 200, 2 lots of 5 plus n minus 1 d is 60,700. Okay, now let's go for S100. Subbing in the numbers, 2, 5 plus n minus 1 is 99 d equals, okay, so we can modify what we've got in our calculator here to save time. Change that to 99 by deleting that, equals 15,350. Okay, then subtract them from each other. 60,700 take 15,350 equals 45,350. Okay, so 60,700 take 15,350 equals 45,350, which is the answer. However, there was a different way of doing this, which I'm going to go through now, using the other formula, the half n a plus l. So alternative method, and I think this half n a plus l formula is best used in situations like this, where the lower limit of a sum isn't equal to 1. Okay, so Sn equals a half n a plus l. Right, so in this case A means something different. A is the first term in the sum. L is the last term in the sum. And N is the number of terms being summed. Okay, so the first term in the sum is the 101st term. So A is the 101st term. So that's first term in the sequence is 5 plus n minus 1 times the difference equals 305 is the first term in the sum. The last term in the sum is the 200th term. 5 plus n minus 1 d equals, so 5 times 199, 5 plus 199 times 3, which is 602. So now let's look at how many terms are being summed. Well, it goes all the way from 101 to 200. So 200 take 101 doesn't quite give us the number of terms being summed because we need to count the first one as well. So add 1, which is 200 take 101 plus 1 equals 100 terms. So now we've got everything we need to put in the formula. So the sum equals a half times the number of terms. First term plus last term equals, and hopefully we'll get the same answer as before, 1/2 times 100, 305 plus 602, which gives us 45, 350, as we did before.